Ramanujan for G is now available on the Google Play Store. Try it out for free.
Yeah, so in the matrices, we'll see the properties of symmetric and the skew symmetric matrices. Properties of symmetric and skew symmetric matrices. Okay, so if A is a square, then A transpose A plus A transpose A transpose A are symmetric matrices. You can write A is square matrix, then A plus A transpose A transpose A are symmetric matrices, and A minus A transpose is skew symmetric matrices. Okay, next property, if A is a symmetric matrix, A is symmetric matrix, then minus A transpose an minus 1 B transpose are also symmetric matrix. Okay, so both property I need to copy, then we'll see some more. First is square matrix, then A plus A transpose A transpose A are symmetric matrices, and A minus A transpose is skew symmetric matrix. And if A is a symmetric matrix, then minus A transpose A and A minus 1 B minus 1 are the symmetric matrices. Okay, next is next if A is skew symmetric matrices, then you can say A to N is symmetric matrices. Next is for all n belongs to n. A to n plus 1 is skew symmetric matrices. Next is Ka is also skew symmetric matrices, and B transpose AB is also skew symmetric matrices, where B is a square matrix of the order of A, right? Similarly, A and B are two symmetric matrices. Then you need to write A plus minus B, AB plus BA are symmetric matrices. B is AB minus BA is skew symmetric matrices. C is AB is symmetric matrices, which is where AB is BA. Okay. So next is A and B are skew symmetric matrices again. So then A plus minus B, AB, BA are skew symmetric matrices. Similarly, AB plus BA is symmetric matrices. Next property is if A is skew symmetric matrices and C is column matrix, then C transpose AC is zero matrix. Is zero matrix. One more, every square matrix A can be uniquely expressed. Okay, can uniquely expressed as a sum of symmetric and skew symmetric matrix as A is half A plus A transpose plus half A minus A transpose. Okay, next thing, A is skew symmetric matrix of part A is. Okay, so let's solve. A is B plus C, where B is half of A plus A transpose, and C is equals to half A minus A transpose. Okay, so like this is your symmetric matrix and this is your skew symmetric matrix, right? So C is half minus 1 7 2 3 minus of minus 1 2 7 3, so that can be half 5 minus 5 0. Okay, so this is your skew symmetric of part A. Okay, so you can copy down this. Repeating given matrix is minus 1 7 2 3, we need to find the skew symmetric of part A. So first we'll let assume A equals to B plus C. So B is half of A plus A transpose, that is your symmetric. Second one is half of A minus A transpose, that is your skew symmetric. Then you need to subtract for the this skew symmetric and you will get your skew symmetric of part A. Okay. Okay, so next is determinant of a matrix. Determinant of a matrix. Okay, So in this, A is equals to A11, A12, A13, here A21, A22, A23, A31, A32, A33. So this is your square matrix. Then its determinant denoted by mod A, or you can say that A will be A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, same. So meaning properties, if you look at the properties for this, so that is mod A exists when A is a square matrix. Next property, mod AB is equals to mod A mod B. Next, A transpose, you can write mod A. Fourth one, KA, that will be K to the power N mod A. Here A is square matrix. Fifth one, A and B are square matrix of same order, then you can write mod AB is equals to BA. Any order same. Next property is a skew symmetric matrix of odd order, then mod A is equals to 0. A is diagonal of A1, A2 up to AN, then you can write mod A is A1, A2 goes up to AN. And the last eighth property will be mod A power n, you can write mod A n, where n belongs to n. So again, I'm repeating one by one. Okay. First one is if mod A exists, then A is a square matrix. Next is mod AB, you can write mod A, mod B. Next is A transpose, you can write mod A. Mod A transpose is equals to mod A. Next is mod KA, you can write K to the power n mod A, where A is a square matrix of order n. Fifth property, if A and B are square matrices of same order, then mod AB is equals to mod BA. Sixth is if A is a skew symmetric matrix of odd order, then the previous one was of for the same order. This one was for the odd order, then mod A equals to 0. Seventh property, if A is equals to diagonal A1, A2 up to AN, then mod A will become A1, A2 to the AN. The last, mod A power n will become mod A power n belongs to n. Okay, so these properties I can copy. Now, properties of adjoint matrix. Okay, so there are 14 properties. We'll write one by one. Properties of adjoint matrices. So A of A adjoint A will be mod A. In, that is adjoint A into A. Okay, here this is always a scalar matrix. Okay, next, second, adjoint A is always A n minus 1. Third, adjoint of adjoint A is mod A n minus 2 of A. Fourth one, adjoint of adjoint A, adjoint of adjoint A will be a mod A n minus 1 whole square. Okay. Property number fifth, adjoint A transpose is adjoint A of transpose. Next, let me write all the properties, then we'll explain. Adjoint AB will become adjoint B into adjoint A. Okay. Property number seventh, adjoint A to the power m is adjoint A to the power m, where m belongs to n. Property 8th, adjoint of Ka, adjoint of Ka, Kn minus 1 of adjoint into A, where K belongs to R. Next, property 9th, adjoint In is equals to In. Next, property 10th, adjoint 0 is always 0. 11th, A is symmetric, then adjoint A is also symmetric. 12th, A is diagonal, adjoint A is also diagonal. Next is property 13. A is triangular, then adjoint A is also triangular. And property 14th, A is singular, then adjoint of A is equals to 0. Okay, so these are all 14 properties. We'll see one by one here. Okay. Okay, so first is A adjoint A is equals to mod A, that is adjoint of A into A. Next is adjoint A, that is mod A to the power n minus 1. Next property is adjoint of adjoint A, that is mod of A n minus 2 into A. Next is adjoint of adjoint A, that is mod A n minus 1 whole square. Adjoint of A transpose, so adjoint A whole transpose. Okay. Next property is sixth, adjoint AB is adjoint B adjoint A. Next, it's adjoint A to the power m, that is adjoint A whole to the power m. M belongs to a natural number. Adjoint Ka, that is K minus 1 adjoint A. K belongs to R. adjoint in, that is equals to in, adjoint 0 will be 0. If A is symmetric, adjoint A is also symmetric. A is diagonal, adjoint A is also diagonal. A is triangular, adjoint A is also triangular. If A is singular, then adjoint A will be equals to 0. Okay, so you can read all these points. Okay, so I hope you got all the values. Okay, so thank you guys. We'll see you in the next lecture.